Hello friends. So in this video we will make a leaf disease telegram board, segmentation telegram board. So let me first run this file to show you how our telegram boards look like. Open my browser. Let me type the command start. Okay, it will tell me that what is the use of this board. Now help command will give me that which commands is used by this board. Then about command which tell me the model which is used by the weights. Okay. Then final main thing that segmentation. Let me select one image. Let me select this image. Wait for the second because see this this portion is segmented with the red color. Okay, so this way we get a segmented image with the and a segmented image is a disease area where the disease is present on a leaf. Okay, this way we segment the leaf. Okay, so before that, let me comment this whole code so that I can explain you one by one that which function come first and which functions come fast, so come later, so that you will not do not get confused. Okay. So before that, the first thing which we have to do is go to your browser, open a Telegram board, and search for board father. Okay. After getting the board father, you have to click on it, click over it, and just type it help. Okay. After typing it help, we'll get this. Click on this and select the name of your board. I am selecting leaf disease segment, and I will copy this whole again because next thing is to give the username of your board. I am keeping the same as of my board name, and last three character will be board, otherwise it will throw the error. This way you will get a token ID, and this is the token ID which can connect to Python file uh, with your board. Let me copy it and change it here. Okay. Okay, so this is the first part, that generating the token ID, and you and give the token variable this token ID. Okay, now we will move to this main function. Now we will create a commands. The first command is start command, second help, and third about command. Before that, we will use this application package and the builder function. Then the token will pass a token ID, and this we use the build function. Okay. After using this line, we will connect the Python file with the Telegram board, and this app act as a reference of your whole board. Okay. Now for creating the command, we will use app handler, and and the package which we use is command handler. And if a person types start, it will activate this start function. This start is basically the function name. Okay. We So this is a function which tell that what this particular Telegram bot is used and what is the use of this Telegram bot. Here you can see that we initializing two parameters, update and callback context. But in this whole function, I am not using callback context anywhere. So because Telegram, when we create a Telegram bot, it has a default structure, or you can say it is necessary to initialize update and context in a function. Otherwise otherwise it will throw an error. And if and in single line I can say that it is a default structure which we have to which we have to follow. Okay, either we use callback context or not, but we have to initialize it. Otherwise during execution of this file it will throw an error. And this callback context basically a toolbox which contain different tools. Like if suppose I want to add a reminder in my Telegram board, I have to use callback context. If suppose I want to store the specific chat from my board, I have to use callback context. But right now I don't want to use these facilities, so I just have to initialize this because of the default structure of the Telegram board. There's no access displayed by the start command. For displaying the message, we're using update.message.reply text. Okay. And use of this async and await I will tell you at the end of the video. Now second command we will create is a help command. Help command give the details that which command is present in this particular board. So same way we have to initialize, update and callback context. And for reply the text in the chat in a board, we have to use first have to create uh, we have to create the string or the information which we have to pass, and then use of reply text. I will pass this help text variable, and the message will display on a Telegram board if a person use type slash help command. Okay. And about command basically give the details of the model which on which this leaf dot py wait file train on. Okay, for that we will uncomment this part about command which give the details of the model which is on which this train on. Okay, you can see the feature pixel level segmentation, overlay unit model we are using, advanced data augmentation is present. Okay, now we have to main thing is that providing the segmentation. And see that photo is not a command, so but photo is a message, so according to that only we have to handle it. So for that we using message handler. Filter dot photo means whenever the user send a photo in a Telegram bot, handle photo function get activated. Wait a minute. Okay. Same way we have to pass two parameters, updated callback context, and this line will there is no need of use for loop. Okay, and this line will select the highest resolution photo which the user passed. Okay, after selecting the photo it will first fetch the image from the server, then we will download that image in a bytes format. After downloading that image into bytes format we have to convert it into a numpy, so this line convert the image into a numpy. Okay, let me explain again. Okay, this line select the image highest resolution image. This line second line photo dot get file function basically fetch the image from the server, and this third line basically download the image into bytes format, and we have to convert that bytes image format into a numpy. For that we are using this I am icode decode I am decode function of CB2. Now we will convert the image into a pill format. After converting the image into a pill format, we will pass that image into object detection image function. Then the compiler move up, and this function get activated. Then the functions get activated. We are passing we pass using this segment function, and from where it's come, come from the segmentation Python file, and there is a segment function is there. So in segment we are passing two parameters, image and color sample, and color sample is this. Okay, and after passing it the compiler move to the segmentation, and let me comment all this. Okay, so the compiler will come to segmentation. After coming to the segmentation, at first we have to create the model for prediction. So this create model function get activated. So here it's get activated, and this for leave basis we are using unet, and its number of classes is number in general will be 3, means we are passing the RGB format images, and classes we have two, that one for the background and 0 for the background and 1 for the leaf. That's why not person here, it's is a leaf disease. So we are passing a leaf disease, okay. And encode weights we are using image weight, and the backbone is we are using ResNet 34. Okay, this way it returned the model. After returning the model we load the weights, and now model is an evolution that we are predicting, not we are not training, predicting. Okay, so that's why model.eval. And this is a transformation that this three lines is important because it is a process to convert the image into tensor and the size of the images, because to predicted model is use of fixed size images, so we have to convert that into 2 into 224 images and to tensor and normalization. Okay, after adding the transform to the image, we use unsqueeze, because during training we pass the images into a batch format. Okay, according to same dimension we have to use for the image. So that's why unsqueeze, basically it add one dimension to the image, and that dimension is known as batch dimension, and its value will be 1, means 1 channel height and width, this way. Okay, after getting the image input tensor with with new dimension of batch, we pass that into the model, and with the torch no grid, means no gradient is there, no operation of weights has to perform, and it just pass the image. And to get the one image output prediction, we use zero index value. After getting the output, just we have to pass the image and output and class colors to a draw segmentation function. Now this is the function which create the blended image or the segmented image. Whenever we pass this, first we is a transparency, that to what amount we want transparency in a segmentation. And first it will use torch dot argument about dot cpu dot numpy. And why we had used cpu first till here we get the prediction mask, predicted mask, which is predicted by model. And dot cpu means if suppose the data in a gpu, I want that data should come from the gpu to cpu. For that I'm using that dot cpu. And this you know that the predicted mass or the output is in a tensor format. Okay, this predicted mass is in a tensor format. Okay, so I want that too for the calculation, because see here how calculation is performing. Okay, so that's why I have to convert that into a numpy. Then after conversion, because image is also used for the calculation, so that's why I have converted image into a numpy. And yeah, and this time I'm using a different variable, image.np. And predicted mass cannot be on cannot have a same size of height and width of the image. It might be possible, so to resize it we are using image dot size. Okay, it will give me the width and height. And after using the cpu resize function, we change the predicted mass height and width. And interpolation dot cp2 is because it's it means the missing pixel will be filled with the nearest pixels value. After that we create a overlay of 0 pixels value, and this height and width will be same of image np. After that we iterate over the class color. It give me class id and color. You can see that it will give me class id and the class color. After that we only change the pixels value where the predictor marks where the predictor marks resides, where the predictor marks is equal, predictor marks values will be equal to the class id. Okay, for example, if suppose I will talk about the first iteration, not first iteration, let me talk about the second iteration, because second iteration is a leaf disease. So according to that, if in all the places where in the predicted mass pixels value will be 1, at that time overlay value will be changed to color, the color value. Okay, for example, np array color value will change. Okay, say this, here we are not passing the integers value. Here we are passing, when we use predicted mass resize is equal to class id, it means we are passing the boolean array. Okay, boolean 2d array we are passing it. And it's change all the pixels value where the pixels value is equal to 0 in predicted mass risk, where all the pixels value at that position, over in that same position overlay values pixel value also changed. Okay, for now blended image will be image. Now here we create a image copy, we create the copy of your blended image. And we only does change in blended image, we just want to change the pixels value where it is equal to the predicted mask is equal to 1. Okay, and same way just we are using cpu bit, and image np is equal to main image 1 minus alpha, you can say 0.5. Overlay will be passing by this modify overlay, and this alpha then we passing the 0. Okay, And same way, only change the pixels value where predicted mask size is equal to 1. After that, we get the blended image. So for better explanation, let me explain you that this whole process with example. Okay, so suppose this is a mask, predicted mask. Okay, suppose this is a predicted mask where one value, this one is the pixels value, or you can say this one represent that this is the area where the disease is present, or this is the area where segmentation has to be performed. And this right now this is in a grayscale format. Okay, this is the overlay. This is the image. Now we are using alpha 005 class color to this is a color which we are using for class index 1. This is a mask, this is overlay, and say this line, what is happening in this line. Okay, this is a predictor mask. I already told you that what is happening. This is the overlay of size of image np. Okay, now what is happening here, let me show you. See this same thing, we are passing mask class id is boolean to the boolean array. So after using this line, let me show you the red and green and blue channel of the overlay. You can see that this is red channel of overlay, this is a green channel and blue channel, and this 255 is the color value. Okay, this is a red channel. See, in red channel pixels value is 255, in blue channel pixel value 255, in blue pixels value 00. Same way it's 255 values are changes, and the pixels value is changed only on those places where mask is equal to class id, and class id is equal to 1 for the iteration. Okay, so only on those places pixel value changes according to color rgb values. Okay, after that you will get a overlay like this. And why we have you can see that this is this 255 is representing the portions where the segmentation has to be performed. Okay, so same way after using this cv2 add weight function and passing this alpha overlay alpha and predictive marks is equal to protect mask is equal to 1. This is because means change only on those pixels value where the segmentation is where only on those pixels value where the pixels value is equal to 1. We want only those pixel value change. That's why I use predicted mask size is equal to 1. Okay, after that we get a blended image. Okay, after getting the blended image, we will come here, we get the image with segmentation. So the compiler come to this place. Now here we have to convert the image into numpy. Okay, it's already we are returning the image on blend in a numpy format. You can see that data type of is nd array, but for the safety side, we again convert that image into a numpy array. And just you can see that for loading the image from the server, we have to first download the image into bytes and then convert that bytes into numpy. Same way, we have to first encode the image into the jpg, and after encoding the image into the jpg, we have to convert that image into the bytes stream. So here conversion of compression of image into a jpg format means encoding is performing. After encoding, we convert the image into a byte stream, and then we return the byte stream of the image. The compiler will run to it, we get the image with segmentation. Now we will reset the file pointer. This time we are not replying with the text, we are replying with the photo. So we are using we are using reply photo function. Photo is equal to image with segmentation, and the things which we want to display below the image, we using relieve disease segmentation. Okay, so the board code I have explained you each and every line. So let me show you the result of it. Go here, go to your board which you have created, leave this is segmentation, start. Okay, start. It will show me the message. Wait for the seconds. See, it's showing the result. Okay, now let me type help, then about, Okay. Now we pass the image for the segmentation. Let me select this image, send, wait for the second. See the area. It will segment the disease area of the leaf. Okay. Now let me select one image more. Which area is good to display? Let me select this one. Okay. See, it's highlighting the disease area of the leaf. Now, uh, importance of this run pooling. Basically, app.run pooling is responsible to respond to the message sent by the user. If I will not use this app.run pooling, then suppose I commented here this line, and now I will run this code. Then the whenever I will write /start, the message will not give any this respond board will not respond to my commands. Okay, so to make the command board responding for the commands, I have to use this app.run pooling. It's important line. Okay, now let me explain you why I have used async await here. See, first use of this await in after every reply to the text, because you know that whenever we use this message, man, the first message will pass to the server, then from the server it passes to the board. Okay, but during transmitting the message to the server and from the board, if sometime some error occur during this process of sending image message from the from image to the server and from server to the board, some error occur. So if I will not use this async and await, if during this condition where the error is there on server, during this time if I will write /help /about, then the board will not respond to the any message, because this time the board is working as a synchronous if I will not use async and await in any function. If suppose I will use await and async, and same error occur that sending during sending message from server to the board, or from Python file to the server, during this time some error occur. But because of use of this async and await, during this time if I write start and slash, the board will respond to that message also. That's why I have used async and await after every message or reply of text. So I have explained you each and every line and what is the use of this line. So if you want more videos like this where I will explain you each and every line, so please like, share, and subscribe. Thanks to all.